Okay guys, so now let's move on to the definite integral section of this chapter. Here we have this question wherein fx is given to us, then which among the following is true is the question. So the question is concerning the point of minima, point of inflection. All these things basically require the knowledge of f dash x, f double dash x. So let's begin with the computation of f dash x. It's pretty simple. F dash x will be x minus 1 into x minus 2 whole square. Not a problem. If this is f dash x, when you put it equal to 0, you basically get x equals 1 and x equals 2. Now, talking about the entire real line, this is 1 somewhere and this is somewhere 2. You can very easily see if I put any number less than 1, this is going to give me negative, this is going to give me non-negative. So negative into non-negative gives me negative. Here it is positive and here it is negative. That means around 1 there is a sign change from negative to positive of f dash. Therefore, this is a point of minima. Right? If this is a point of minima, what is the minimum value of the function at this point? It is given by f of 1. F of 1 is integral 0 to 1 t minus 1 t minus 2 whole square. See, 0 to 1 t minus 1 t minus 2 whole square. Evaluate this, what do you get? This is t minus 1, t minus 2 whole square is t square plus 4 minus 4t dt. Fine. This eventually gives you 0 to 1. This is t cube plus 4t minus 4t square minus t square minus 4 plus 4t dt. So you have t cube, then you have minus 4t square minus t square, so it is minus 5t square. Then you have 4t plus 4t, that is 8t minus 4. This eventually turns out to be t to the power 4 by 4. Let's just directly write it, or okay, let me just write this step. T to the power 4 by 4 minus 5t cube by 3 plus 8t square by 2 minus 4t. And the limits are from 0 to 1. So you get 1 by 4 minus 5 by 3 plus 4 minus 4. So you get what? This is 3 minus 20, so it is minus 17 by 12. So you have at 1, the function's value is minus 17 by 12. So 1 comma minus 17 by 12 is a point of minima. Now if I am talking about point of inflection, for that I will have to compute f double dash x. Fine. Let us talk about the computation of f double dash x. So this is f dash x. What is this equal to? Let's write it down. X minus 1 this is x square plus 4 minus 4x, which means x cube plus 4x minus 4x square. X cube plus 4x minus 4x square minus x square minus 4 plus 4x. This gives you x cube, then you have minus 4x square minus x square, this is minus 5x square, and after this you have 4x plus 4x, that is plus 8x minus 4. When I am talking about f double dash x, this eventually comes out to be 3x square minus 10x plus 8. So when you break this up, what do you get is 3x square minus 6x minus 4x plus 8. This gives you 3x, x minus 2, and then you have 4x minus 2. So you are left with x minus 2 and 3x minus 4. When you put this equal to 0, you basically get x equals 2 and 4 by 3. Around 2 and around 4 by 3, f double dash changes its sign and therefore 2 and 4 by 3 are my points of inflections. They are the points of inflection. And at these points of inflection, what are the values of the function? You are going to calculate f of 2 and f of 4 by 3. You will be finding that f of 2 actually comes out to be minus 4 by 3 and f of 4 by 3 comes out to be minus 112 by 81. Yes, this comes out to be minus 4 by 3 and minus 112 by 81, and hence you get that 2 comma minus 4 by 3 and 4 by 3 comma minus 112 by 81 is a point of inflection. Moving to the next question, we have I is given to us and we are asked to evaluate this integral's value. Okay, let's do that. Now in here, if you can see, the integral as it is can be broken down as the sum of two integrals. I can write this as integral from minus pi by 6 to pi by 6, pi upon 1 minus sine of mod x plus pi by 6. This is one integral, plus 4 times integral minus pi by 6 x to the power 5 whole upon the same thing 1 minus sine of mod x plus pi by 6 the dx. Now you can very easily see this is actually an odd function, right? Because this is an odd function, this is an odd power. See, here x is not playing any role. Whatever you plug in, it is going to give you plus only. But because of this 5 power, this complete integrand is becoming an odd function. And therefore, from minus pi by 6 to pi by 6, its integral is 0. So, my complete integral is only going to be determined by this, because this is not odd, this is actually even. Because this is even, I can write this as twice of 0 to pi by 6, 1 upon 1 minus sine of. Now see, in 0 to pi by 6, x is positive, so mod x is x plus pi by 6 dx. That is it. This is what is my integral I, because the other part has already vanished, it has become 0. Now over here what do I do is, I take x plus pi by 6 equals t, that gives me dx equals dt, fine. But when x is 0, t is pi by 6. X is 0 means t is pi by 6, and x is pi by 6 means t is pi by 6 plus pi by 6, which is twice of pi by 6, which is pi by 3. Therefore, what do you get in here is, you get I is equal to 2 pi integral, when x is 0, t is pi by 6 and this is pi by 3. Then you have 1 upon 1 minus sine t, right? Dx turns out to be dt. So what you do here is then, this is pi by 6 to pi by 3, you multiply and divide by 1 plus sine t, that gives you, this is 1 plus sine t. In denominator you have 1 minus sine t into 1 plus sine t, which is 1 minus sine square t. 1 minus sine square t is cos square t dt. This eventually gives you what? Pi by 6, this is pi by 3. 1 upon cos square t is sec square t, plus sine upon cos is tan, and 1 upon cos is sec. So now things are pretty good. This is 2 pi sec square t, integration of sec square t is tan t, integration of tan t into sec t is actually sec t, from pi by 6 to pi by 3. This gives you what? Already you have 2 pi. What is tan of pi by 3? It is root 3. Plus sec of pi by 3 is 2. Why? Because sec is 1 upon cos t. Cos of pi by 3 is 1 by 2. So 1 upon 1 by 2 is 2, minus tan of pi by 6 is 1 by root 3, again minus sec of pi by 6 is 2 by root 3. Now see, root 3 minus 1 by root 3 is 3 minus 1 by root 3, which is 2 by root 3. So plus 2 by root 3 minus 2 by root 3, this gets cancelled out. You are left with 2 pi into 2, that is 4 pi, and that is what is your answer. Your answer turns out to be option number A, which is 4 pi. Cool enough? Moving on to the next integral, we have 0 to pi by 2 sine cube x into cos x upon sine 4x plus cos 4x. Let's talk about this now. Okay. Now in here there is one very natural thing which I would like to apply, because the integral is from 0 to something. What is that property? 0 to a fx dx is equal to 0 to a f of a minus x dx. Okay? If I apply this, my integral turns out to be what? 0 to a sine cube of pi by 2 minus x is cos cube x. Cos of pi by 2 minus x is sine x. Sine of pi by 2 minus x whole to the power 4 is cos 4x. Similarly, this is sine 4x. Right? If I am saying take this as 1, take this as 2, now I am saying add 1 and 2. What do you get? I plus I becomes 2i. This is 0 to pi by 2. Sine cube x cos x plus cos cube x sin x. I can take out sin x cos x common. I will be left with sin x cos x common. I will be left with sin square x plus from here cos square x. So I will have sin square x plus cos square x, which is 1. 1 into sin x cos x is sin x cos x. Whole upon sin to the power 4x, because that is what is the common thing, the LCM, plus cos to the power 4x dx. Now let's separately tackle this particular thing, that is the denominator. If I talk about sin 4x plus cos 4x, I can write this as sin square x whole square plus cos square x whole square. Okay. Now you know 1 plus cos 2x is 2 cos square x. I am missing that 2. So I multiply and divide by 2. So I get 2 cos square x. Divide by 2 whole square, which is 4. So that comes out. Plus again 2 sin square x. And outside you have 4. Now you know that 1 plus cos 2x is 2 cos square x. So I replace this by 1 plus cos 2x. And this is 1 minus cos 2x. Just open this up. 1 by 4 is common. Keep it as it is. 1 plus cos square 2x plus 2 cos 2x. Then this is 1 plus cos square 2x minus 2 cos 2x. So minus 2 cos 2x plus 2 cos 2x. 1 plus 1 is 2. Cos square 2x plus cos square 2x is twice of cos square 2x. So 2 comes out common, cancels out with this. I get 1 by 2 times 1 plus cos square 2x. So the denominator has turned out to be 1 by 2 times 1 plus cos square 2x. 1 by 2 times, so it becomes twice of sin x cos x whole upon 1 plus cos square 2x 0 to pi by 2 dx. Just take cos 2x equals t. Let me rub this now. Take cos 2x equals t. What do you get? If you put cos 2x equals t, you get minus 2 sin 2x equals dt by dx. Or I can say minus 2 into 2 sin x cos x dx equals dt. So 2 sin x cos x into dx is actually dt upon minus 2. Right, first thing. Next thing is that when x is 0, t is cos 0, which is 1, and when x is pi by 2, cos of 2 into pi by 2, which is cos pi, that is minus 1. So your I integral turns out to be what? 2 sin x cos x dx is dt upon minus 2 upon 1 plus t square, and limit is from 1 to minus 1. But I want to get rid of this minus sign, so I basically write this as minus 1 to 1, and I am getting rid of this minus sign. This is what? 1 by 2, okay. Now this is, okay, so this is 2 times I and not I, this is 2 times I. 2 times I is 1 by 2, so this becomes 4 times I. Let me just get rid of this. This implies 4I will be equal to tan inverse t from minus 1 to 1. Tan inverse 1 is pi by 4 minus tan inverse of minus 1 is minus pi by 4. So this becomes pi by 4 plus pi by 4, 2 pi by 4, which is pi by 2, and therefore I turns out to be pi by 2 into 4, which is pi by 8. So your answer is pi by 8. Clear enough? Moving on to the next section, we have for k coming from the collection of all natural numbers, ak is this. Then we need to answer the following options. Okay. Here also, if you can see, I have something like 0 to something. So again, it's very evident to talk about the same property that we used in the previous question. If I take this as equation number 1, I am saying ak is also equal to 0 to 1, x is replaced by 1 minus x, sine of, again x is replaced by 1 minus x, so you get pi minus pi x whole upon x is replaced by 1 minus x plus, again you replace x by 1 minus x, you will just be left with x, and k to the power, when you replace over here x by 1 minus x, you will be having 2x minus 1 dx. Now this, if you simplify further, you get 0 to 1, 1 minus x, this is sine x because sine of pi x, this is because sine of 180 minus theta is sine theta. Now what you do, you divide the numerator and the denominator by k to the power 2x minus 1. That is going to give you k to the power 1 minus 2x, and here you will have 1 minus x, k to the power 1 minus 2x, plus x will be left alone because I have divided dx. This is your ak. Take this as 2. Now add 1 and 2. You get twice of ak is what? Twice of ak is 0 to 1. See, what is it? 1 minus x sine pi x, k to the power 1 minus 2x plus x sine pi x. So you basically get sine pi x common. Inside you have x plus 1 minus x into k to the power 1 minus 2x. In the denominator you have the same denominator, which is x plus 1 minus x times k to the power 1 minus 2x dx. So clearly this is getting cancelled out. So you are left with twice of ak being equal to integral 0 to 1 sine pi x dx. Okay? Now, what is this? This is minus cos pi x by pi from 0 to 1, which eventually gives you what? Which eventually gives you minus 1 by pi sits outside. You have cos pi, which is minus 1, minus cos 0, which is 1. Okay? So you have, this is minus 2, so you get 2 by pi, and here it is twice of ak. So ak comes out to be 1 by pi, and this is true for every k. That means value of ak is not depending upon k. For every k it is coming out to be 1 by pi. So one thing is true, that ak is independent of k. Moreover, if I talk about the second one, that you are adding ak's from 1 to n and then multiplying the sum by 1 by n. It is actually 1 by n times a1 plus a2 plus a3 up till an. Now ak for every k is 1 by pi. So a1 is 1 by pi, a2 is 1 by pi, a3 is 1 by pi, and so on, an is 1 by pi. So basically I am adding 1 by pi plus 1 by pi n times. This is a1, a2, a3, a4 up till an. So this is n times 1 by pi. And already you have a 1 by n. So your answer is nothing but 1 by pi. Moreover, if I talk about a1, a2, a3 and so on, the sequence, a1 is 1 by pi, a2 is 1 by pi, a3 is 1 by pi and so on. So the sequence is becoming a constant sequence. Any constant sequence is an arithmetic progression as well as a geometric progression. So because I am getting the same values of a1, a2, a3 and so on for every ak, basically I am getting the same value 1 by pi. I am having this sequence as a constant sequence, and so it is both an AP as well as a GB. Moving to the next question, what is it that we have? Let's see. For a greater than or equal to 1, I of a is given to us as an integral depending upon a. Then we need to answer the following queries. Let's talk about them now. What is it that we have? Now, if I talk about this integral I of a, here you can see is cos inverse of ax. You already know that sine inverse ax plus cos inverse ax is pi by 2. So cos inverse ax is pi by 2 minus sine inverse x. So I can use this to actually simplify my given integral. I of a will be what? I of a will be integral from minus 1 by a to 1 by a. 2x to the power 6 plus 2x to the power 4 plus 3 cos inverse x is what? Pi by 2 minus sine inverse x. This many times pi by 2. So let me just bring it outside. Dx minus, again from minus 1 by a to 1 by a, 2x to the power 6 plus 2x to the power 4 plus 3 into sine inverse ax dx. Now it's pretty evident that this is an odd function, and therefore the value of this integral is directly equal to 0. So the value of IA is completely going to be determined by this integral, which is even. So you in the next step write it down as what? You in the next step write it down as twice of. So twice of, when you write 2 gets cancelled. 0 to 1 by a. 0 to 1 by a, 2x to the power 6 plus 2x to the power 4 plus 3 dx, which eventually becomes what? 2x to the power 7 by 7 plus 2x to the power 5 by 5 plus 3x from 0 to 1 by a. Now this eventually gives you 2 by 7 a upon a to the power 7 plus 2 by 5, and here it is a to the power 5 plus 3 upon a. So your I of a is actually equal to this. That is what is given over here. I of a is pi into 2 upon 7a7 plus 2 upon 5a5 plus 3 upon a. So this is definitely correct. Now one more thing, if you understand from here itself, let me tell you, I can extract a out. I will be left with pi by a, and I'm going to have 2 upon 7 a to the power 6 plus 2 upon 5 a to the power 4 plus 3. 1a has been extracted out. Greater the denominator, lesser is the value. So if I am saying consider pi by a 2 upon 7 plus 2 upon 5 plus 3, then obviously this expression has an a is greater than or equal to 1. A is a good, nice, proper positive quantity. So now I am making the denominator less, I am making it free from a, I am making it free from a positive quantity. Lesser the denominator, greater is the fraction, and greater the denominator, lesser is the fraction. So this value is definitely less than or equal to this value. And what is this value? This value is nothing but it comes out to be 129 by 35 into pi by a. So what do you eventually get is, you eventually get that I of a is less than or equal to 129 by 35 times pi by a. Clear? A option happens to be the correct one. Is it understood? That's how you deal with questions on definite integrals, so practice them nicely. That's it from my side. Thank you.